Okay, so in this video we're going to be looking at how what we've been talking about with exponents can be applied to a specific kind of story problem dealing with what we call compound interest. Now let's talk about interest for a while. Sometimes interest is applied at the end of the year, in which case we call that annual compound interest. And in this situation, it's not as common, but so you're not required to memorize this formula. There's a better formula that we're going to be looking at here in a second. But for this formula, like I said, this formula represents when interest is compounded, meaning it's figured into your account at the end of the year. Where P in this situation represents principal. Now principal represents the amount of money invested, or if you're borrowing money from the bank to purchase a house or to purchase a car, that would be your principal. So it's the original dollar amount. Where R is your rate, that's your whatever the interest rate is, and T is going to be the time in years. Now, like I said, that doesn't happen very often. In most savings accounts or even credit card loans or mortgage loans, anything like that, it's compounded more than once a year. If money is compounded semi-annually, the interest rate at each compounding is half the annual interest rate. Meaning, they take that, if it's compounded semi-annually, that means twice a year, they take that original interest rate and they break it up. And so if your interest rate is 4%, halfway through the year you're going to get 2% of the interest, and then at the end of the year you're going to get the other 2%. So what we say, the way that we say that is we say that it's compounding twice each year instead of just once. Now our formula that we're going to be looking at is this one. This is the one that we're going to be using most of the time because, for example, if you have a credit card loan, you're going to be paying interest every month. So that interest rate, whatever the interest rate is going to be, it's going to be divided by, or the N is going to be 12 because it's been compounding 12 times during the year. So again, P is going to be the amount invested or the amount borrowed. R again is your interest rate, and it's going to be the number of times it's compounded in a year. And T again is going to be measured in years. So if I have a situation like this, where I have $10,000 that's placed into an account that pays an interest rate at 5%, how much will be earned in the account in the first year if the interest is compounded as indicated? So we're going to have a total of 3 problems, each of which deal with the same $10,000 and the same rate of 5%. Now let's talk about percents for a second here. We can never do anything with a number written as a percent. We always have to change it to a decimal. So 5% is 0.05 as a decimal. You always move the decimal place 2 places to the left, or think of it this way as you're going to divide by 100. So if it's compounded annually, that means that the number of times it's compounded just once a year. So N would be 1. Remember, if you divide something by 1, it's going to stay the same. So in this scenario, our equation would be A equals our principal, which is $10,000, times 1 plus our rate, which is 0.05, divided by N. Again, in this case, our N is going to be 1. So it'd just be 0.05 divided by 1, or just 0.05. And it's going to be, so we want to figure out how much is going to be in the first year, so we're going to put 1 in there as our exponent, because 1 times 1 would be 1. So what we're going to do is we're going to take and figure this out. Let's go ahead and look at your calculators how we would do this. So we're just going to type this in as 10,000, and then in parentheses it's going to be 1 plus 0.05 parentheses, and our exponent's going to be 1. Enter, and I get 10,500. Now be very, very careful. They want to know how much will be earned. The total amount in my account would be $10,500. That means that I earned $500. That's my answer. I want to be very careful with that, because if you say 10,500, you're saying that you earned $10,500. Well, that's not the case. We started out with 10,000, so the new amount the amount that we gained in interest was $500. That's what we're looking for with these three problems. You always want to be careful. Make sure you're answering the question. Now, if they say how much will be in the account, how much total would be in the account after 1 year, in that case, you'd say $10,500. But that's not what they're asking for. Let's look at the next one. It says, this time it's being compounded semi-annually. That means, in this case, n is 2 because it's being compounded twice a year. Now you might think, oh wow, that's going to be great because now instead of $500, it's going to be $1,000 because it's going to be doubled. Well, that's not necessarily the case. Let's look at what we would have here. If we have our original amount is still $10,000. Our interest rate is 0.05, but again, following this formula, this time our n is going to be 2. So it's going to be divided by 2. The rate is going to be divided by 2, and then our time is going to be multiplied by 2 as well. Well, 2 times 1 is just 2. So going back to our calculator, now here's something nice about the CAS. If we don't want to go back in there and, well, yeah, we're going to have to start it out all over again. I'll show you something next time around. Okay, so we're going to take $10,000 again, times 1 plus 0.05. This time we're dividing that by 2. And our exponent's going to be 2, because it's 2 times 1. So now we get $10,506.25. But that's, remember, that's the total amount that we earned is $506.25. Now remember, the reason why it's not that big of a difference is because we still have the same interest rate. Instead of that interest rate being broken up or being applied at the very end of the year, we're taking that interest rate and we're dividing it in half. So after 6 months, you would get part of your interest that you earned, and that gets put in your account. But now what's going to happen is with the remaining 6 months, the remaining half of the year, what you gained to begin with, that little bit of interest, is getting reapplied. So you're gaining interest on top of your interest. So you're going to gain a little bit more. It's not a whole lot, but it does make a slight difference. Now let's see what happens when it's being applied quarterly. So this would be where n equals 4. So again, we're dealing with, let me do a different color. Dealing with the same amount. Still $10,000. Still with the same interest rate, still 0.05. This time it's being compounded 4 times, so quarterly, so 4 times throughout the year. Okay, this is what I was referring to earlier. I don't want to have to retype this again. So the only thing that's changing is my exponent. This time is going to be 4. And my denominator is going to be 4 as well. And if you didn't catch what I did there, if you hit the arrow up 2 times, it'll select what you typed in previously. And then if you just hit enter, it'll copy and paste it into a new line for you to be able to edit. But if you just hit the up arrow 2 times and try to change something up in the original problem, it's not going to allow you to do that. We have to hit enter, so that way it copies and pastes it into a new spot, so now we can go through and edit it. So now when I hit enter, I get $10,509.45. So obviously here we earned $509.45. So the difference between being compounded annually and being compounded quarterly, so 4 times in the year, was only just under $10. Granted, it will accumulate, and if we had done it instead of quarterly, if we had done it monthly, so every month, which is more likely to happen, that's the way banks work, and that's the way credit cards work. In that case, obviously it'd be a little bit more than that. And also, this doesn't consider in if you continue to add money into the account. This is just if you have this amount, you deposit it at the beginning of the year, how much will there be at the end of the year? So to summarize what you need to know for this first segment of this lesson, is you want to make sure you understand how to find general compound interest, because this can be used whether you're trying to find annual compound interest or whether it's one where it's compounding semi-annually or monthly or quarterly or even daily. So please make sure that you have this formula memorized and you know how to use it. In the next video, you'll be learning about how to compare different interest rates using what we call annual percentage yield. So good luck.